So I was asked by somebody to design a case around this, and I asked for like dimensions because I don't have this thing. I have a pie, and the other thing is I asked if they wanted to be able to plug stuff into it, so I'll have to have all the ports exposed still. So let's see, a couple of things to consider. These wires, which I told them I'd have to shorten them so the box is smaller. You can design them where, alright, so let's look at this. This is a top view. So let's say this is the pie and this is the battery. Something like something like that. Yeah, it's like the switch right here, or this right here is right here, and then the wires are here. Here's the pie. Let's see, this edge right here. There's like HDMI port right here. Actually, it's be on this side. The point is, you could make it like this, where your case is like that, and then, you know, the wires just snake from one to the other. But then the issue is, I don't know, you still could use this. Ports would be there, accessible. The other thing is the box needs a cover. So, say it's like, I don't know, this deep. This is a side view. Then if you look at it this way, you'd have like a hinge over here somehow. And then it would open, you know, that way. Around this hinge. So yeah, this is one way, and then the other way is to stack them. This is a side view. This would be the battery section. The switch is accessible through here. This switch, and then the pie is on top. The issue with this way is you have to like somehow get the battery down there first, and then the pie on top. If you look at a top view, you would want a gap on this side for the wires to go into. Let's see. The wires are like here, so they'd jump downwards like that. So you could have like little ridges, and then you would put the battery down in there like at an angle to get past the ridges. Screw them down, screw the battery down the holes, and then you put the pie in. Maybe the pie has like, you know, 2 holes here you screw it down with, and then you would have your 40 header pin here exposed. You got holes for the ports, video even, and then the lid is on top. You know, opens and closes around this point here. So that's what I'm gonna go for. I do wish I had this thing, but I work with the main dimensions. Like, I know this point here, I know this point, I know this point, and then I know the width, I know its length, width, and then I know the height, which I think this thing is the tallest. Then you'd give some extra room for the wire. This fits this, like they're supposedly the same size, feather board or whatever. So yeah, so I'm gonna get a model. I have a Pi Zero model somewhere already. Model something with this. I know some of the dimensions, and then I'll start designing the case. I use SketchUp and Cura slicer. SketchUp with some plugins. I'm supposed to learn Fusion, but I haven't had the time to put into it. So yeah, let's get started. So here's a Pi Zero, and part of a 20 pin header. I don't have a 40 on hand, but I just needed to know the height. But what you want is a caliper. I'll use inches because I'm a scrub. But yeah, so you need one of these to get dimensions. And I work with the major dimensions, so I want to find the position of these screw holes, how long it is, how wide it is, and how tall it is, particularly with this, because that goes, you know, on top. And then your connectors go over that, and that adds more height with the wires. So you have to add some space. So I mentioned the battery is supposed to, like, they're the same size. You can see here it stacks. This is by Waveshare UPS hat. So if you have it stacked like this, that's a lot smaller. You know, like you would have a different box design. This thing is pretty neat. Like, it's got, I mean, personally I wouldn't put an entire operating system on a little small screen like this, but it's cool. Yeah, so if it was like this, then the box is a lot more straightforward to design. It's smaller. You don't have to worry about like wires have to go around. Less material too, so the print is faster. And that's, you see the pins here, like you would have a hole for those so they can be used in the future. There's one other thing I did not consider. I'm glad I saw it. There's a charging USB thing here, so you need a hole there at the bottom of the case. I really need to find dimensions for this thing somewhere. I can estimate it, but it's like 3D printing is not something you want to like get wrong, particularly on stuff that takes a long time, because it's a waste of plastic. So there was a change in plans. It turns out this thing is stackable. So, and also these headers are soldered, I don't want to say backwards, but they should be that way. So it's flipped around to fit it, but you can work with this. And then if you see the bottom of this battery hat, there's nothing here. And since I don't know the height of this component here, this might be taller than the rest. I'm just gonna add a, you know, something that's, it's hard to say definitely taller because I don't know how tall these are. That's my cat breathing. Yeah, so I'll just add like a bump here. The board rests on, and there will be pegs that these go on top of. And then since it's a brick, like you can't really screw down into the plastic, this would be the bottom of the case. So yeah, this thing will just sit in there, and then the lid will keep it together. It'll sandwich like a cross here. I'll keep the pins exposed and all the ports accessible still. So here I'm in SketchUp. I imported there's a Pi 02 model, but they're like the same form factor. And I only care about the major dimensions, which is the position of these holes, the length, width, and then the maximum height, which is the header height. And then I have to make this brick with that same thing in mind. So I would just draw like a box extending downwards, and then keep in mind like a slot for the switch. There's a charging port over here, which I thankfully have the dimensions from wave shear for that. And then he's got the brass things on the top versus the bottom, so it changes things a little, but like I could use that for the bottom little height thing and the pegs. Oh crap, I just forgot. You won't have... I'll have to do something else. I was thinking I would have like the plastic pegs go into this, but if it's together like this, then you'll have to not support that, support it somewhere else. This will pretty much just drop into like a box type case with holes, and then the top case will sandwich this thing down so it sits still inside the case, and then you still have access to like the card, this, and these. So yeah, it's not really anything crazy. And then I'll just round the edges so it looks nice and put a I wonder where it makes sense to put a hinge. You want a hinge. Because the hinge is nice. Like you have it like on the side. You have a screw. You can just open and close it and put another screw on the other side to close it. But that's complexity. Like if these things stick outwards, your case will have to go around that somehow. Or no, I guess you could. I can't draw. You could have a case where it's like this, and it goes along. And that's like a solid, you know, like if you look at it sideways, it's like three-dimensional. What? Oh yeah, so that could... man, that's tough though, because these pin headers, I'm not gonna do that. I'm just gonna have it where there's like a screw here and a screw over here, and then you put the lid on and the screws go down on the top to join the two halves together. This is like the bottom case, top case, just like that. That should be enough to keep the thing together. Alright, I'm gonna get to it. Actually, forget what I said before about not needing all the dimensions. I have to measure. I'll put it on here, like the SD card, HDMI out, USB, and then the camera. And then that'll factor into the design of the case. Okay, so at this point I have a rough like volume to work with and where all the parts are, and then in order to be like sure that it'll be correct, I'll just add like a low tolerance, you know, like a big gap around the ports so that they will fit. And yeah, I've got, let's see, where is it? In the like time lapse, I already showed this, but you can see how it stacks. Yeah. Yeah, the switch is over there. It looks right, you know, but it's not because it's flipped. SD card is over here. It's also underneath. So yeah. Anyway, I'm just gonna like draw a border around here, extrude it upwards, round the base, put some like clearance. I don't want to say pegs, they're like risers that avoid the actual parts. So like, I don't know, maybe one here, one there. And then yeah, this thing will just drop in there. Then you have a top, and then screw, and it'll be good. And then we'll see if all the dimensions are right. First print. The other thing is, unfortunately, this is slightly off, and the thing with these PCBs is they're made together out of like a larger board, so I don't know how many there are, but there's like a perforated edge, you know, and you like snap them apart, but that changes the width of the boards a little bit unless you take like a razor and cut the edges off, the burrs. So that is something to consider, but you just use like sloppy tolerance to get around it. Alright. I did realize this is not the bottom. The battery goes here. That's why it's blank. Plugs in right there. So I'll just have to get a shot of the bottom from somewhere and look at it. Figure out where I can put risers. So in the time lapse I showed this trick to get dimensions from a picture. Oh, that's my stomach. Hungry. So you take a picture like this and you have a known dimension. Alright, let me... I'll draw a line from here to here. I set that to the width from the dimension image. 30 millimeter. 1.181. Here to here. 1.181. Yes. Okay, so this is to scale. It said the radius is like 0.181 or something. No, 0.118. Yeah, it's a little off. I don't like it. Don't like it. The issue is this picture is probably not head on. So we'll just give vague dimensions. It looks like if I put something like right here, it'll be fine. So I put a support want it to be able to sit on it. I could put one like over here, right here. It's like a circle or something. How big? Let's see, point. Yeah, it's a bit big, but it'll work. That, and then I'll just put one over here. This is like not scientific at all. I'm just 0.1, 0.1. So these will be like pegs that are printed, and they'll be at the bottom of the box. Stick the board on. And then the cover going on top sandwiches the boards together, so it's not gonna like wobble or anything. Could be further over here. We'll move it. Anyway, so I'll add that to the bottom of the case, and then this will just rest on it. Okay, so this is what I have now. This hole here and this one are random. They're just air vents in case all the plugs are used. There will still be like a way for air to get in and out. And yeah, you could change that design, but yeah, so now I'm just gonna save this as like another thing. Backup. So get that backed up, and then take this out. thing to know about 3D printing, you've got like a base that you print from. So this is like the horizon, the floor, the ground. And then if something's not touching it like this, you'll have to generate a support, which Cura will do. So there will just be like a support there. There'll be supports here between these holes in the ceiling. And then this part here, you'd rotate it since the bottom is like narrower than the top. Just flip it around like this, and then you also put it against the ground. Line it up on this axis with here. And drag it over. And then okay, hold on. Let me see. This is a tool to inspect, oh yeah, the solids. Make sure like it's not broken. Have to explode. Crap. Hopefully that's fine. It is, thank goodness. And then there's a plugin. I have export STL. This is a plugin here, solid inspector. So you export this. I designed this in inches, but you export it in millimeters. And then you open up your slicer. Drag it in there. There it is. And then see here, like generate support. You slice it. Oh, 3.5 hours. That's not bad. The walls are 0.1 inches thick. But anyway, the thing you want to check is the preview. So go down to 0 where it like is just starting, and then watch the parts as it rises. Make sure there's nothing like missing or like a weird gap or something. There seems like a gap around here, which is odd. Well, no, these are supports, that's why. Okay, so that's the plastic wall there, and you'll see the support goes and meets the actual part. Wall's there, hole. Check this side. Those are supports over here. Go up. These are the pegs that the battery board sits on. It's not secure because those screw holes are already taken on the board. Goes up. There's holes for the screws, and that's supports. Yeah, so it looks good. Then you just print it. 3.5 hours. And if something's wrong, you just modify the dimensions and do it again.